Good afternoon. Welcome to course Thermodynamics of Materials. Today we are into lecture 175 and 176. We are discussing construction of stability diagrams. And we will construction of stability diagrams. 6 examples we will consider. The first one we started system MO involving M solid, M liquid, MO solid, MO liquid and the gas phase containing oxygen. And this is the diagram, figure 1a. This is the final diagram, but we will explain and we will construct this diagram. How this diagram is constructed line by line. There are several lines there, so this we will discuss. And also there are dotted, or the significance of these dotted lines also will consider. These are metastable lines. So this we will consider. And remember, this figure is actually for the second exam. This is the first example. 6 examples we will consider. This is the first example. This is the second example, so don't consider this and ignore this diagram. We concentrate on this diagram. And remember, we are up to certain point, so we will begin from that. What is, yes, that is actually, as I told you, yes. So today we will consider the construction of the diagram. Remember, and I started construction with first example, say first case or first reaction rather. So what is this topic is now continued from the last day's class, continued from the last day's class. Last day's class. So what is construction of the diagram This is now we'll take up. So this is several lines, you see, 1, 2, 3, 4, 5 lines at least, 5 lines. So 5 reactions we'll consider, and they will be shown by straight line, by curve. They will be represented by these lines, and then actually we'll give the final shape to these curves. Okay, eliminating some lines, we call this metastable lines, some extensions. This we will discuss. Triple point, stable metastable arrangement, all such things will be discussed today, and we will have an understanding. And remember, this diagram is drawn ln pO2 on the y-axis against 1 by T on the x-axis. This is this, and something I have written here, figure 1a, stability diagram for the system MO. Something I have written here, dotted lines. And this actually, I tell you what, this I will actually, when time comes, I will explain this line, this part, okay, this writing, okay, this dotted line, this a couple of sentences, one sentence or 2 sentences are written here. So this I will discuss, okay, when I will talk about the metastable lines. So this is something, so later on. And what else? Well, I can give you good idea that I tell you what you see about diagram. This final diagram is, this is actually stability diagrams. This gives the stability fields of different phases. For example, this is metal solid stability region, metal solid. So here, yeah. Then this is this whole field, this area is for metal liquid stability field, and this is metal oxide. This is metal oxide, and then this one is metal oxide liquid. And gas phase always is there, as you can refer to the y-axis, there is pO2 for pO2s are shown here, okay, and temperature you will get from x-axis. So this is the things, okay. So but how these diagrams are arrived at, we will discuss construction of the diagram. First examples, as I started in fact last class. So let us begin with this same lines. Consider the equilibrium. Consider the equilibrium involving M solid and MO solid and the gas phase which is O2, oxygen. Oxygen, gas phase, oxygen. So start. So what is the equilibrium? Then let us write this out. Metal solid plus half O2 gas is metal oxide solid. Metal oxide solid. Okay. So this is called this reaction 1. So what you get from this start, delta G01. See, you see how this line AB which represents this equilibrium, I tell you beforehand. This AB, which is actually the relation of ln pO2 against 1 by T. So this line, how often, this is the beginning. This is write the reaction and then get the delta G0. Then you will arrive at the equation of a line, straight line, and that is given by the line AB here. So delta G01 is what? A plus BT, the standard form, remember? A plus BT. Often I will write this. Okay, almost every case. A is delta H0. You must know that you write this. A is delta H0 and B is minus delta S0 standard. And so remember this is A plus BT. These are known quantities. These are both known quantities from data book. So you have data, just no problem, write that A plus BT. The general form is what, as you know, is minus RT ln K, the equilibrium constant. Okay, what is that? Express, give this minus RT ln K is what? Activity of product, which is MO solid, activity of M solid, and pO2 power half. This is obtained. So of this, activity of MO solid is pure solid. So 1. This is also metal is also pure. So these are all 1. So what you are getting from this? Half RT ln pO2. So or should you write this, or well I will write here. I will write here. Okay. Or ln pO2 is what? ln pO2 is what? 2A over RT plus 2BT 2BT over RT. This T cancel. So what you have finally is 2a over r times 1 by t plus 2b by r. Okay, this, so ln pO2 against 1 by 2, 1 by t relationship, which is a linear relation, a straight line, and this is actually like equation AB. So let us write this. Okay, hence ln pO2 versus 1 by t, you plot. This is the reason why you are plotting. I am plotting ln pO2 versus 1 by t. Then it will be linear. We prefer linear presentation instead of non-linear. Okay, so how this can be non-linear immediately if you plot pO2 instead of ln pO2, and here instead of 1 by t or 1 by t even, but if it is pO2 it will be exponential relation, so non-linear. But linear we prefer. That's why often you have this log term. Log on the y-axis, sometimes log both here, later on you will see log on either axis. Okay, so ln pO2 versus 1 by t plot is linear. Is linear. This is line AB. Remember this line AB is this. Okay, now linear, the slope being so linear right here, right here is linear line AB. The slope, what is the slope? You get from this slope being 2a over r, 2a over r, which is negative. 2a over r being 2 over is negative. Why it is negative? Because a is delta H0. Delta H0 enthalpy, standard enthalpy is negative for this oxidation reaction. We know that oxidation reaction. So we may write this, note this point. Since why it is negative? Since delta H0 is delta H0 of reaction 1 is negative, and I am assigning some value for some to facilitate some discussion. Okay, to explain something. So now about the slope. Okay, to compare this slope and that slope, which is coming later. So that's why is negative, is minus 40 kilojoule say just for example. Okay, not to put, let's say please say okay, just negative sure, delta H0 negative, but the value is just considering, assume it is minus 40 kilojoule. Okay, so giving this part is okay, minus 40 kilojoules is okay. So note from here. Okay, from here you just write here. Note along the line I've said already, along the line AB, what happens? Follow this. Along the line AB, who exists? Both this equilibrium exists, means both these solids, both these solid, metal solid and metal oxide solid exist, are in equilibrium, are stable, variously call it, variously express it. They coexist in equilibrium, they coexist in stable form, they both are stable. But remember, above this line, one phase stable, only one of the two, and below the line, the other one will be stable. For example, if you increase this oxygen pressure, obviously this will move and metal oxide will be stable. So metal oxide will be stable, and below the line metal solid. This I have shown here. See, okay, this you see here I have, okay, this for rough work. Above the line metal oxide solid, below the line metal solid. Along the line both. This is always common feature. This comes. Okay, again and again in every case. So along the line, above the line, below the line. Along the line, I repeat, M and MO together, both present, both stable. And above the line, MO stable. So here I have written here, here, follow here. Above the line, or above we may call it to the right, on the right of the line, same. Above or on the right, metal oxide stable. Below or to the left is metal solid stable. Okay, this is clear. So along the line, maybe both M solid, both M solid and MO solid coexist along with the gas phase. Gas phase is always present, primarily seen on the y-axis, along with the gas phase, which is nothing but oxygen gas here. So oxygen along with the gas phase coexist. So they coexist as stable phases. So these two, M and MO, as stable phases or equilibrium phases. Stable phases. Very good. As stable phases. It is as stable. Above the line, this is about along the line. Along the line, above the line. Above the line maybe MO solid, is stable. Plus the gas phase always, plus the gas phase is stable, and below the line below the line M solid, again you should mention plus the gas phase is stable, are stable. Okay, is stable. That's it. So you have got all information about the line AB, the equation, and what it signifies along the line, above the line, below the line. Okay, hold it there. Next, let us. This is A. Yes, A. Okay. Anything else? Okay. No. B. Let us consider next. Next is B. Consider the equilibrium. Again, consider the equilibrium. Consider the equilibrium. Involving, okay, metal solid, involving metal solid and metal liquid. I will write this. Metal solid goes to metal liquid. Goes to metal liquid. Call it equation 2. This was 1, this is 2, okay. Delta G0 2 is what? Right? Delta, start from there. Delta G0 2 is A prime plus B prime T. The write A plus B T, but A prime, since it is different reaction, we change A prime plus B prime T. Again, A prime B prime, you know, is what? Known quantities. A prime B, A is, right? A is delta H0 and B prime is, I'm sorry, A prime, B prime is minus delta S0. Okay, very good indeed. Okay, remember here in delta H0, just this will be required, both will be required a little later. So A is delta H0, you know, this is a melting process, enthalpy of melting is positive. And B is delta S0 is, you know, entropy change. Liquid has more entropy than solid, so positive, but minus delta S0 is negative. Delta S0 is positive, of course, okay, minus entropy of melting, okay, so negative is what you should write is what F prime plus B prime T is 0, is what is 0, because the standard state delta G0 is 0, both are at standard state, and at equilibrium delta G0 is 0. So, or what you get, T is minus A prime over B prime. Now what is your right? Minus A prime over B prime. So A prime is positive, but B prime is negative. So whole thing is positive, as it should be. This is the melting point. This is the melting point. So positive, obviously. So T is positive. Positive is what? That is the melting point. Tm of M, melting point. This point. This is what TMM. I have written C. This point C is TMM. I have written here. Okay. So I didn't get space here, but this is the TMM. C point C TMM. Also, I will give you the line first, then you'll get. So this is a TMM. So okay, this is point C. Yes, written here. Is TMM. Point C in the diagram. C. Delta H2, you may note here like this. Delta H02 here. This is delta H0 for the second one. Delta H02 is our enthalpy of melting. This one is plus 5 kilojoule. Plus 5 kilojoule say. Previously it was minus 40 kilojoule for this reaction. This is 5 kilojoule. For example, just to illustrate the whole thing. Okay, this will use full later. Okay. Now this giving this, so this is okay. So what else? So what line represents this equilibrium? Metal solid, metal liquid. I give you what line? What line represents this equilibrium? CD. I am sorry, CB or BC. CB. Draw a vertical line from this melting point. Okay, this point, this value, this is the temperature. Draw a vertical line. And this line already AB was there. They intersect at B. So I will more about this later on. Okay, just a vertical line. So this CB represents this. Like AB represented This metal solid plus half O2 is metal oxide. So each reaction you have a line. So 5 kilojoule cell. So now what you write? So the vertical line. So the vertical line drawn upward through C drawn upward through C, which is BC, as you will see, which is the line BC, the vertical line drawn to line BC, you may write line BC, line BC. Line BC let me write here line BC, and BC represents this vertical line BC represents the equilibrium. The equilibrium under static. Which equilibrium under static? Metal solid goes to metal liquid. Equilibrium 2 will represent the equilibrium. So very good. So again, along the line, both metal solid and metal liquid. To the right means 1 by T increasing means T decreasing. So metal solid alone, and on the left metal liquid, well, at higher temperature. 1 by T decreasing means higher temperature. So along the line, above the line, or below the line, or on the right, on the left of the line. So here I shall write along the line BC, both right here, both right here, let us not waste this one, both M solid and M liquid coexist, on the right of the line, on the right of the line, M solid, and on the left M liquid will be stable. And you can specify the gas pressure. Okay. Though oxygen is not involved here in the reaction, but oxygen can coexist. Okay, at the pressure which is relevant at the state you are considering. Okay? But on the right, metal solid. Suppose here, then that is corresponding oxygen pressure. But oxygen has no part here, has no role here in the reaction. It is metal solid goes to phase transformation, metal solid to metal liquid. But anyway, so mainly it is along the line, vertical line. On the vertical line, you have both coexist, metal solid and metal liquid. On the right of the line, metal solid. Right here means lower temperature. 1 by T higher means lower temperature, metal solid, and on the left, metal liquid will be stable. So this is about this. Okay, this is over. Once this is done, see next one. Which reaction you consider? See, you have there is a sequence about considering. You can easily. One is metal solid, metal oxide. Next, metal solid, metal liquid. The third will be obviously which combination? Metal liquid and metal oxide with oxygen as a reactant. So what is the next one? Metal, consider the equilibrium. Consider the equilibrium. Involving, it is better I write here, involving. Here also I forgot to write, or rather I avoided. Consider the equilibrium involving, here you wrote, involving metal solid and metal oxide A. So here also you should write involving, here also writing what? Metal liquid, metal oxide solid and O2 gas and the gas phase O2 and the gas phase which is O2. So how will this is the next case. So represent this metal liquid plus half O2 like this, clearly like this, half O2 instead of solid, that's right, liquid, metal liquid plus half O2 is okay. So you see everything, top thermodynamics of materials.
Slight.
Okay. Here everything is okay, huh?
That is okay.
This one is okay. It's okay. Thank you. Lecture number is okay.
Lecture number is understandable, but the thermodynamics, this material.
Half O2 is MO solid. Again, similarly, just similarly, give the level reaction or equilibrium, whatever you call it. Okay. Now start like this: delta G03, delta G03, like this. Okay, like exactly like this. A double prime plus B double prime T. Okay. A is, again you write A double prime is delta H0 and B double prime is minus delta S0, as you know, is what? Minus RT ln K is minus RT ln K, expression of equilibrium constant activity of MO solid, M liquid, pO2, power half. Okay, these are all unit activities. And metal liquid is also pure metal liquid. So one. So what you have got here, half RT ln pO2, half RT ln pO2, like last time, half RT ln pO2, or now right, ln pO2 is what then? Exactly 2A double prime by RT plus 2B double prime T by RT is what? RT. So TT cancel. So what you have obtained? 2A double prime by R times 1 by T plus 2B double prime by R. So this is like this is like this. Okay. Hence, this will write, hence ln pO2 hence ln pO2 versus 1 by T relation is what? Versus 1 by T plot will be what? Is linear, because it is a straight line. Again, like this. This straight line is linear. I tell you, remember, pO2 versus 1 by T. What is your answer? What relation it is? pO2 versus 1 by T. 1 by T. Doesn't have to be T. pO2 versus 1 by T. What is your answer? ln is taken. You don't consider ln. It will be, pO2 will be exponential, non-linear. The answer will be, it is non-linear. Or pO2 versus T. That is also more complicated. Non-linear. But ln pO2 versus 1 by T is linear. This plot, what is this plot? I am telling you beforehand what these two lines is covered. This is the line BD. BD. We'll extend this for later on. But BD, suppose with this segment that I show, that is a stable section. BD, this is the line that represents this equation. BD. See, BD. Along the BD, who are present? Metal, liquid, and metal oxide. Let me write first. The plot is linear, hence this plot is linear. And what is that? Line BD. Line BD. The slope being what is slope? Tell me. 2a double prime. 2a double prime by r. 2a double prime by r. This is also negative. This is also negative. Why negative? Because A is enthalpy of this oxidation reaction is negative. So this is negative. But what is remarkable here? It is negative. 2a by r was negative. This is also negative. But which is more negative? Or less negative? Answer is this is more negative. That's why I quantified these values. 2a by r, etc. Negative is minus 40. Okay, that is the slope. Okay, this I will show you here. Okay, that a double prime will be more negative than a prime. Okay, sorry, or a is here, a for the oxidation for metal solid. So let us say being is negative and is more negative than, not only negative, more negative. That means this slope will be more negative. Means this is negative. Follow this. This is negative. This is the one that I draw now is more negative. Means both are negative, but this will be steeper. Will be steeper. The slope will be steeper. So this is steeper. BD is steeper than AB. Is more negative than 2a by r. 2a by r. Hence, the slope of BD 2a by r. Okay, sorry. Hence the slope of BD, like this. Hence the slope right here. Hence the slope of what line BD is steeper. Steeper than that of AB. AB is what? Metal solid and metal oxide. Metal solid plus half O2 is metal oxide solid. And what is the BD? Metal liquid plus half O2 goes to metal oxide solid. These are the difference. But they have their representation will have in the form of a straight line with different slopes. One is Both are negative. One is more negative, another is less negative. So steeper. So BD is all three lines here. Remember, this part is which line? This part, which line? Line AB. Means AB. This part, M solid and M liquid. Which part is what? BC. BC. And this one, which line? BD. BD. So here actually you have three combinations you have considered. Okay, this is fine. See. So will you write here? I think it is better. I give a star here. Star, double star maybe. Since I give it one star here. Shall I remove this? System MO is still continuing. So I should not remove that one. Top line is there. Construction of the I write here. Let us try writing here. Double star. So what you write here? BD like this, along the line BD, above the line BD, below the line BD. So right, along the line BD. So you write this, along the line BD. Who are present? Both present. M liquid and metal, MO solid. See, this reaction, M liquid and MO solid. M liquid here everywhere M liquid, and here everywhere metal oxide. So this it is relating M liquid, connecting M liquid, MO solid through oxygen. So along the line, what line? BD. Okay, what is this line? Along the line BD. So along the line BD, both metal liquid and metal oxide solid are stable phases. Okay, coexist. Coexist means coexist are stable phases. Coexist at equilibrium. Stable means equilibrium. Stable state, equilibrium state. Coexist. Okay. On the right or above, whatever you call it. On the right, on the left. On the right or above. Anything you write. On the right means above also. On the right of the line, right of the line, who is present on the right? MO solid. MO solid. The line MO solid, and on the left of the line which one? M liquid. Remember, M liquid are stable. Okay, very good. So I will demonstrate that this is why this is more negative, because you see more explanation. I'm just showing you here. I'm taking this line off. Removing these lines. Instead, I'm showing you why it is more negative. You follow this. Follow the delta H0. So this is 2A double prime by R, the slope, and the previously it was 2A by R. Both. So you see, this is the explanation for the slopes. Of what? AB and BD. Lines AB and BD. AB and BD. What is this? I am giving you short. What you have got? What is this? M solid, why you see follow, plus half O2 gas is MO solid. Delta H0 is how much? I gave you, this is, delta H0 is A, this value I consider, what value I consider? Delta H0 is minus 40. So write minus 40 kilojoule. Minus 40 kilojoule. And what? Metal solid to metal liquid, what is this? Second one, yeah, here it is. Metal solid to metal liquid, delta H0 is positive. And what value I consider? Plus 5 kilojoule. So metal solid to metal liquid, I am just reversing this, okay? Metal opposite of that, it obviously will be, if it is plus 5, the opposite is minus 5 kilojoule. So if you combine these two, what you get? Metal solid cancel. You have metal liquid plus half pO2 gas is metal oxide solid. Delta H0 is how much? Delta H0 is minus 40 minus 5 is minus 45 kilojoule. Give a bracket fencing here. Minus kilojoule. Kilojoule I have given it? Yes. See. So compared to minus 40, it is more negative for this. Which delta H0 means this A double prime and A. What is the slope? Slope is based on A double prime and A. Is nothing but 2A by R. Here 2A double prime by R. So A and A double prime control the values, okay? They govern the values. So A and A double prime, which is a delta H0. So delta H0 in the first case is minus 40 kilojoule for this. Yeah, the slope is governed by minus 40 kilojoule and this is minus 45. This BD minus 45. So that's why it is steeper. Okay. So first these three things over. Now have some discussion. Stable metastable concept. Okay. Actually, you might say, see, one thing, one student should ask, sir, this line very good, sir, but we have doubts. Sir, you have drawn this line, but you have stopped here. Why? Why you have stopped here? Why not extend it further like this dotted line? What is the name? This was one by one. Say AB line. So AB line you have drawn up to this point. Why not beyond that further? So like say where up to where? This is BA and this side is BA double prime. So AB further extended to BA double prime and then consider. Similarly, sir, why B, CB? Why not past B to this C prime? How do you know it will stop here? Or why not this part is stable? Why not this dotted part is stable? Here in this case also BA prime is not stable. How do you know, sir? Why BA should be stable? If I argue, sir, and let me finish first. Then BD here, sir, you have stopped here. Very good. But I could have actually extended here, down there. Down there, what name I have given somewhere, I cannot avoid this. D prime is somewhere D prime should be there. Have I missed this? D prime actually, no? D prime. I didn't get, I am writing. I have missed this. So B, say extension of this, BD. See, downward extension to D prime, all prime, dotted line, prime. Sir, extend this. Suppose I argue, sir, so this line, this dotted line, this dotted line, and this dotted line, these three are the stable lines. Instead of these, the solid lines, BC, BA, and BD. What would it be? It is actually what? Okay, just against this, what you are considering against this, C prime B, keeping B at the center, B C prime, B D prime, B A primes are these three lines. Why you don't consider? Why you consider this? This is the question. I give you the answer. These are actually metastable segments. Then how do you know, sir, these are metastable? Yes, this thermodynamically, these are metastable. Thermodynamic principle, activity, free energy, this I will show you. Okay, but before this, the rule, very easy rule you follow. Then first you draw correctly with some thumb rule, with some, okay, tips. You follow. What is this? For some properties I am saying. This is a triple point. B is known as a triple point where three phases meet. Metal solid, metal oxide solid, metal liquid. This is the triple point. Around triple point, these three stable lines that I have drawn, as I have named them, are center, around which these three lines lie. Okay. And these three metastable lines, dotted lines also, around this triple point. So 6 segments are there. 3 and extensions 3. 6 segments are there. Of these 6 segments, 3 will be stable segment, remaining 3 will be metastable segments. And another interesting thing is that stable and metastable all alternate around the triple point. She said this is stable, then dotted, metastable, then stable again dotted, metastable, again stable, solid line, again next dotted, metastable, again stable. This will always happen. This arrangement I will show you here. Okay. Then from this, so either these 3 or that 3. Now there is actually which are compatible. You will see they are mutually compatible. Stable lines are mutually, various ways I am trying to help you. Various ways to know which are stable, which are metastable. Now stable lines are mutually compatible, very positive. They don't have any conflict among themselves. They are compatible. While metastable are mutually inconsistent or incompatible. They are not in agreement. They are not in harmony. There is a clash, contradictions. That I will show you. But stable lines, mutually consistent, compatible, in agreement, very easy to identify. Either these 3 or that 3. I remember what I said, alternately. So obviously 2 choices. Suppose this is a stable, alternately, stable, stable. Either this answer, alternatively, if you say no sir, this is the stable. So that is possible. That is possible, not possible actually. If you can argue actually, this is the stable, this dotted, then this will be then metastable. If it is stable, then it will be metastable. Stable, metastable, stable. That arrangement will be thermodynamically wrong and, as I said, mutually incompatible. This I will explain. So now actually I will discuss about stable, metastable. This what I told you. Actually, let us write down few lines. Okay. So I think this part is over. These 3 lines have been drawn completed. Remember, it's all completed. Drawing of this line, of completed. Okay. Let me remove this. Instead of actually here. And this is good enough. Okay, now so here it was note. As I have already told you, so it will be helpful for you now. Note. Okay. Right. Note. After this, actually, this is metal liquid. Yeah. This part. Note now. This is a discussion on stable, metastable, about the 3 lines, 6 segments here. Note BA prime BA prime, as I told you, BA prime dotted actually. So these are already told is the metastable extension. Is the metastable extension of the stable line AB. AB. Similarly, BC prime and BD prime are metastable extensions of the stable lines BC and BD respectively. So we see that around the triple point B, triple point B, this is a triple point, this is the triple point. These three lines as well as three phases. Which phase? Metal liquid, at the start, metal solid, metal liquid, metal oxide solid. They meet at this point, triple point. So around that, we see that around triple point, where three condensed phases, where three condensed phases metal solid, metal liquid and metal oxide solid meet. Condensed phases, three condensed metal solid metal meet. Okay. Okay, very good. So meet. Around the triple point B, bracket closed, around the triple point 6 line segments radiate out. Three of these are stable lines. Three of these are stable lines and the remaining 3 metastable. And the remaining 3 are metastable lines. Metastable lines. Okay, these are the metastable lines. As a general rule, rule stable lines and metastable lines alternate. It is better I write here alternate around the triple point. As shown in figure 1b and 1c. Figure B, 1c. Okay, this I will show you. This I will show you here, sure. 1b and 1c. Okay, I am showing it. You just look at this. Just example. That's an example. You follow this. You follow this. I am drawing something. Let me draw. Oh, sorry. Draw. Okay. Now this is the extension of this is down. Extension of this, and extension of this is now so 6 segments around this triple point. So if it is stable, suppose you choose or you propose or you consider stable, then every other, if this is stable, then this will be stable. So I have shown by solid lines. So solid, what is called stable. Then again alternate, skip this, again stable, which means metastable also alternate. So this will be metastable. Again alternate, metastable. So you have understood this. This is one. Finally, metastable will be removed. They will not be, since they are metastable, they will be removed from the diagram. But because this, you have to identify whether it is stable or metastable. Other option is what? This is your, suppose this is your figure 1 arrangement, and this called figure 1b. This is your figure 1b. 1c possibilities of opposite. Opposite is what? You do this. Instead of calling it stable, call it metastable. Instead of calling this stable, call it metastable. Instead of calling this stable, metastable. Then this will be stable, this will be stable, and this will be stable. So you mention this stable. Say now it was metastable before, but now you consider, because see, you don't know which 3 are stable arrangement and which 3 metastable. So suppose if you consider this stable, then this will be stable. Every other. I am very sorry. What I have considered? Yes, I have correct. Previously it was metastable, now it is stable. Stable. and this is metastable, 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 metastable. No problem. No problem is you don't know yet which is correct, figure 1b or figure 1c. What I said, you should know that thermodynamics will detect which is genuine and which is fake. So finally this I tell you, I write also here, okay. These are. Now one, how to know this, I tell you. Let me remove this. Okay, sorry. Wait a bit, hang on for a moment. I will explain you. It's okay. Very good. So this is figure 1c. 50 minutes or 55 minutes?
1 hour 6 minutes gone.
1 hour 6 minutes gone. 54 minutes.
54 minutes left.
Okay. This is figure 1c actually, you know. 54. Okay. Okay, 1c. This is 1c, figure 1c. This figure 1c, 1. I tell you what, I give you the easy way. Suppose I am taking these examples. I will show you, you can easily detect thermodynamically. Because what I said, the stable lines will be mutually compatible, friendly, in agreement, harmony. Metastable lines are in conflict among themselves. They don't rely each other. They have different versions about the stability. So they contradict each other. So metastable, ruled out, and finally removed from the diagram. They will not be seen. During the construction you have to, because initially you don't know. When you have investigated, you have tested, then you have found, oh, these are the genuine arrangement. I have written something here on top of the diagram which you have not read yet. Now is the time to read. Dotted lines are metastable. Metastable extensions of stable lines past the triple point. That you have seen. Past the triple point, okay? So it's a past the triple point. So it's an extension past the triple point. Okay? So this fine, discard finally all metastable lines to arrive at the stability diagram. So here I have shown, because I like to finally remove. Once you have learned, I'll finally remove, and this I'll keep this solid lines only. Means what? A, B, C, B, D, D, E, D, L. The extent, this C prime, E prime, A prime, B prime. I'm sorry, not B prime. B prime is not okay. A prime, C prime. Well, this A prime, and so all primes actually. What is the D prime? D prime is down here. D prime is where? D, B, D, BD, yes. I just wrote D prime. All this lines, this BD prime, all primes will be removed. I finally remove this. I will remove like this. But before this, I want to establish how. See, because there is now still you are not sure which one is correct. But compatible. Follow this. I am showing you here. I am just copying this part. This part. Okay. Here it is better. I show you here. Okay. Because otherwise I thought actually you will, okay. So I will show you here. Show you here. Huh? So this I am copying. This line, and steeper this line. You see. See, these I have copied. I am giving the name, just copy. I am referring to figure 1A. Refer to figure 1A. Okay. B, tell me C. Tell me A. And D. Happy? What I have labeled, that is very important. I have said metal solid. This is metal oxide solid. And this is metal liquid. I am sorry. Yes, correct. This is the stability domain. So you see, why this is actually correct one. See, they are not in conflict. Why? According to this line AB, see, compare their versions. According to AB, along this which are present M and MO. Correct? Above the line in this region, follow me. Above the line, this region is according to this line AB is for metal oxide stability. Good? And you consider DB line. Here, this is metal liquid and metal oxide. Here also similarly, along the line metal liquid and metal oxide, but above the line or on the right, metal oxide. So according to this line, this region is stability for MO solid, and according to this line also, this region is stability for metal oxide solid. They are in agreement. No conflict. Repeat. Above this line, above this AB line, metal oxide solid. Again means this region. Above means this region. And according to the line DB, above this is mean for metal oxide solid. Because it is metal liquid. Which curve it is? Start with this. Metal liquid, metal oxide. Above metal oxide, below metal liquid. So this part is metal oxide solid according to BD. Similarly, AB is for which line? M solid MO. Along with oxygen. So don't consider that. So that is always there. So metal solid, metal oxide. Above metal oxide. So this region is metal oxide. According to this region is metal oxide. In perfect agreement. Means these are stable components. If it were unstable, metastable, there would be conflict, which I will show you, which I will demonstrate you to your full satisfaction. Or you might say, sir, these two may be coincidence. So can you show me with this line? This line also see? See? This is the coexistence of metal liquid and metal solid. To the left, metal liquid stable. To the right, metal solid stable. So this region, metal solid according to this line. And according to this line, this region already I have said metal solid, because this is metal solid, metal oxide, above metal oxide, below metal solid. Means this region is metal solid according to AB, and this region, the same region is stable for the line BC. The same region is stability for metal solid according to line BC. So BC and AB says the same thing. AB and BD says the same thing. BD and BC says the same thing. Means they are stable. Stable arrangement. I will now show you. I will draw you. Again, I will draw you. This one, the dotted ones. So remember, dotted one was here. Okay, I will show you. Okay, dotted one. Achha, here it will better. Now you consider the dotted one. Dotted extension. water extension, this metal solid. Don't forget extension. So here you see if you consider this, okay. So this line is what? See, follow. Consider dotted combinations. Consider the dot. So understanding is important here. Just not taking down notes or going through the notes is not enough, or books or anything. For understanding will be good enough. So I have extended. These are the metastable lines I have drawn. Okay. Pretending these are stable. So now tell me what is this? This is the extension of this line. Extension of this. What is this line? Stands for metal liquid, metal solid coexistence. Extension. So here also same. Metal solid. You write here short. Metal solid this side and metal liquid the other side. Like this I have copied here because I don't know. So metal solid along the line, metal solid, metal liquid coexist. Here also do the same thing. Here what and what? Little bit extend so that this away from this. Okay, for clarity, this is what? Metal liquid and metal oxide coexistence. So if this is this extension also same, metal liquid here, metal oxide solid. You write this, okay? Metal liquid, metal solid. So above metal oxide solid, here above metal oxide solid, below metal solid. It's okay. So above metal oxide solid, below metal liquid. So this, and third one is what? These are explained. This 1, 2, 3. These are explained. Okay. I am encircling the new one. This I have introduced new. New means on metastable I am arguing in favor of metastable combination, which will turn out to be metastable. I am arguing in favor of that. Suppose I consider this, and what is the third line is this one. Also you extend this so that you understand. What is this line? It is what? Oh, sorry, incidentally remember. Metal solid, metal oxide. This extension means the same. Metal solid, metal oxide. Above, below, along the line. This is actually extension of this. Remember this one. This is metal solid, metal oxide. Means this one. Metal solid, metal oxide. Okay. So this one. Okay. Now you see what happens. You ask each of them what is. Forget about the stable lines. Only concentrate on the dotted, 3 dotted. Okay. This is not. This is stable. This is stable. Already stable. I am arguing for the untruth, for the wrong, for the incorrect things. Arguing in favor. So according to this same way, you ask it and ask this. This dotted and this dotted. There are the alternate. This every other. This next. This next. Till next this. Okay. So suppose this is stable now. Then it is stable. This will be metastable. Stable, metastable, stable, metastable. That way. Okay. Every alternate. So these two you are asking. What is the, according to this line, this metastable line, this space above this space is stability field for what? Metal oxide solid. Above means above, metal oxide solid. And according to this one, the same space, same. It is better I don't draw this. I remove this. Then you will be in a better off. Now you see. Only the dotted, the wrong combinations are there. See, according to this metal oxide solid, according to this metal solid. See, it says no, it is the stability field of metal solid. And it says, this line says, it is the stability field called metal oxide solid. MO and conflict. Again, you may argue it is a matter of coincidence. No, you try another one. So this and this and this. See, according to this space is stability field for metal oxide, and the same space or same region is stability field for metal liquid according to this metastable. So there here metal, yes, it says metal liquid stable, it says metal oxide solid stable, in conflict, incompatible. Similarly here, this it says who will be stable according to this line, it says metal solid will be stable. This line metal solid, and according to this one, this say it says this line, this will be metal, this will be metal liquid, it says metal solid, incomplete. So you understand this. So this is the reason actually why finally, so you figure out this is a wrong line, this is wrong, and from the removed from this diagram. Okay, so maybe if these are wrong, then finally what you will do, suppose these are wrong combination, then you finally remove this, only these three lines, as I said, discard these three lines, these three metastable lines. So if I have actually, let me give you, I'll discard at the end, but it's okay. Shall I will not remove this in case it helps you. So so let us take down next is so alternative 1C 1C, figure 1B 1C. So it is better I remove this top lines, these are all over. About the slopes, stiffness of the slopes already discussed. Okay, so let us write down few lines here. So mutually compatible, the term mutually incompatible, that will be used now. Okay, so it is right here. So from this point, as it you start here. Okay, triple star maybe, triple star. So let us write down. So now one of these two arrangements means figure 1B and 1C. Now one of these two arrangements is thermodynamically correct. Is thermodynamically correct. And the other, while the other is not. While the other is not. The three lines in the correct arrangement, are thermodynamically compatible. And they are called stable lines. I'm removing the first line. Okay, and they are called stable lines. They are called stable lines. In contrast, the three lines. In contrast, the three lines in the incorrect arrangement are thermodynamically thermodynamically incompatible. They are compatible, incompatible. Incompatible, and they are called metastable lines. They are called metastable lines. Next, what is the comment? The metastable lines are finally removed from the stability diagram. What is the diagram? Stability diagram. Figure, for example, figure 1a. Full phase. Although I have not removed, but I just wait for this discussion. I will remove finally, and I will show you exactly clear, nice picture. Only stable lines. That I will do. But this is figure 1a. This is okay too. Very good. Best. Now, okay. I'll take up the next job. Construction of other two lines pending that I'll take up. These lines yet not taken, DF and DE. I'll take up before, but let me finish this. So it is removed. Here also I have mentioned that they discard finally all metastable lines. Now I tell you how you proceed. Actually, when you take up a case, first you draw the line. Suppose you draw the line, see, then add the 2x. Oh, sorry. Bapu? Papa? একটু স্লাইড করে গেছিল, একটু তুই দেখো কি অবস্থা আছে ওখানটা, তখন ঠিক করে দিতে হবে, একটু স্লাইড করে গেল, আমি ঠিক করে দিলাম।
ঠিকই আছে, ওকে ওকে, ইটস ওকে ওকে।
এই নিচেরটা উপরটা দেখুন, আর পাশগুলো দেখ।
না ওই কোর্স থার্মোডাইনামিক্স ইজ কাট, টোটালি কাট।
টোটালি কাট তো? আচ্ছা, একটু ইয়ে করবো আমি। নাও বেটার
বাট স্টিল দ্যাট ইজ নট ভিজিবল ইয়েট।
সেটা আগেই চলে গেছিল, ঠিক আছে, এটা হচ্ছে কিছু এখন ঠিক আছে তো।
Starting from the Gibbs, it is visible from the Gibbs phase rule, okay. And lectures 175-70 that is visible.
আচ্ছা।
Okay.
So,
no, lecture is also cut, slight on the top cut.
Top cut? Is it okay?
No. You check it from this side. I'm going there. You come this side. Just you go there. Check. You go check.
You have guarded actually the right hand side should be correct. Is okay. His right hand side is okay. Gibbs phase rule okay. Lecture little bit. Lecture is okay. Lecture little bit. Slightly change. I will tell you which direction it is moving. Slightly increase, decrease the slope. It is better. Towards better. Further maybe a little bit further. No, don't shift at all. Slope only. Slope, slanting.
No, I'm maintaining the symmetry.
No, don't do that. Don't shift at all.
Okay.
Don't okay. At all. No, you're not required to do that. Again return to previous one. Slowly.
Okay.
Now lecture is totally out.
No.
Shifting is not required.
No.
The Gibbs phase rule lecture is not out.
Okay. Is this visible? This side?
It is compatible. This is here. This is.
Yes, stable. Stability is maintained.
Yeah, it is okay. Okay, that's fine. It's okay. It's okay. Uh, how to improve this?
No?
No, it's okay. No. That it has not helped.
It has not helped.
Other way then. Opposite.
Opposite. This?
Maybe better further.
Further. Now?
It's gradually increasing. Improving. Further. The
No?
same way further or further. Lecture is okay now. It's
Now
okay.
this
Better.
will show a tendency
And now
to slide.
tendency to slide.
Yes,
Right? So,
yes.
it is not good. Very better. This is enough, no?
Mm.
This is better. Oh, thank you. Thank you very much. Aste. It's okay?
Lecture is visible, but that is course thermodynamics.
It's okay. It's okay. Don't do it. Okay. So, yes, what I said, what I wanted to tell you, see, I'm sorry for interruptions, okay? This actually, the board is actually slid. Yeah. It's right, okay? That's slightly, okay? So I have readjusted it, and now you see, now how you draw this, once, suppose you draw a line, you do not know where it ends, where it will happen. 6 segments, which is stable, which is metastable. So you see, I have done this way. You follow me. So this is the metal and metal oxide. This is metal above metal oxide. AB, just line AB you consider. Or how to identify stable combination and metastable combination. So one by one I am showing. AB. I will consider AB, BC and CD. Then you will understand. How will approach? You draw AB. AB, since it is above it what? So I write here, above it metal oxide stable, below metal solid. So you, not only AB, you don't stop. Here you have suppose you have drawn this way. So this end also metal oxide above, metal solid below, and that end also metal oxide solid above, metal solid below. Say A prime. That end you don't know. Now you don't know. Still don't know which is metastable. There is this is one. Similarly, consider BC. So this side is metal solid. I write here metal solid, metal liquid. Vertical line, metal solid, metal here. Yes. I have written. And here see top also metal solid, metal liquid. Both ends I have actually correctly same thing I have written. Metal solid, metal liquid. Then third line is BD. Here also BD is extended here. Here what you know? What you know about this BD is what? This is BD. I have written here. BD is where? What I have written? BD actually I have written here. Metal. This about metal liquid, and metal oxide. Sorry, metal liquid and metal oxide. Metal liquid, metal oxide, and here I clearly have written metal liquid and metal oxide. I didn't get space there. So 6, 1, this place, this end and that end. First line. Second line, this end and the other end. And third line, one end and the other end, both ends. You are writing same thing you are writing. Now you are judging, okay, which will be, it will be stable, metastable, the combination. For example, here you see, you found that it is actually metal liquid, metal oxide. Then, as I have already explained you, this is metal liquid this side, metal oxide that side, and according to this line, metal oxide, this and this then would be the stable one. So this says metal oxide, and this line says metal oxide, same. So metal oxide stable. This is once in one case you get the matching agreement, means all other cases you get the agreement, matching. And in one case you don't get the matching, mismatch, means all cases is mismatch and they are metastable. For example, now you understand. So metastable, so ask this one here. According to this one, according to this line, this side is metal oxide solid, this dotted line, metal oxide solid, and according to the next metastable is metal liquid. Metal oxide solid, metal oxide liquid. That means they are actually really they are metastable. This is how. So both ends with this, and then you check which are compatible. Means every other it should be. It should be. So either this, so only two possibilities then. If you have 6 segments, only two possibilities. Every other, three lines stable, 3 line metastable, and every other. That means so 1, 2, 3, 4, 5, 6. So 1, 3, 5, or 2, 4, 6. So no problem, okay? And compatible means in all cases compatible, and incompatible means in all cases. So you have no trouble finding out which is metastable stable. So now, given this, you have now understood. So all dotted lines should be removed from the diagram, which I will do now. Okay? So it looks good actually. It looks good. So I'm removing. You follow me. So I'm removing all this unnecessary. E prime, no, dotted out. See, you look the, it will now look nice. All out. Oh, here something I have written, sorry, additional explanation. I'm coming to that. That is still additional explanation. C prime. So remove this. Here also remove this. Okay. Okay. Very good. Here also. Remove this. Okay. Here. Another thing I tell you, before since I'm removing here, shall I explain? Okay, where I'll explain? Where I'll explain this? Here. I'll explain this one. This is actually one thing I tell you. Another way, but nice understanding of thermodynamics, that thermodynamics will tell you what I tell. Follow this. Actually, I have removed this diagram. Activity. Acha. You follow this. Oh, okay. You follow this. Let me finish this part. I remove this though. I'll remove finally. Acha, tell me. You follow this. This curve AB. Tell me. Coexistence of metal solid and metal oxide. Below metal solid, above metal oxide. Then if I ask you, what is the activity of M below? Metal solid is stable. What is the activity of M? 1, sir. Because metal solid, pure physically present metal solid. So activity of M is 1 here. Along the line, there also metal solid present, coexist with metal oxide. So both are 1. Fine. Above the line, metal oxide solid is present. Metal is not. That means what is the significance of this? You should note that. That means above means where a metal oxide solid is present, means above these locations, what is the activity of M? M is not there. Less than 1. Doesn't exist means what is the activity of M with respect to pure solid M as the standard state? Less than 1. Hence you don't see it, it's not visible. It is not physically present, absent. It may report it in the form of vapor pressure. Since activity less than 1 means there is vapor pressure, but this is unnecessary. This is actually an additional point. Vapor pressure, but not as solid. So activity of M with respect to solid standard state is less than 1. Note this. So this line AB says, this point, I give a point. Do you see the point? Oh, this is actually too long. this point. Is this line AB says this activity of M is less than 1. You ask this line, this gentleman dotted, I am not removed. This is the extension, vertical extension. Remember, this side is metal solid, lower temperature, metal liquid. So this is metal liquid. I am showing once more. Once more. What do you mean? This is actually okay. I'm sorry, but I have removed this. This point is also additionally reinforce your knowledge. Thermodynamic more with activity and free energy. I'm showing you why stable, metastable. First, I've said how to identify mutually compatible. Now another way. So this line is the extension of this. The same thing will happen. Metal liquid, metal solid. I will remove this. This side is metal solid. Okay. Extension. Okay. Metal liquid, metal solid. So what is the activity of M solid? What is the activity of M solid? Here, at this point, to the right, means this point included. To the right, what is the activity of M? I have written. See, metal solid is there. So activity of M solid with respect to solid standard state 1. And according to this line, AB line, so this was actually BC prime. According to BC prime, the activity at this state, point mean state of M with respect to solid standard state, solid M standard state is according to this AB line is less than 1. Or according to this line BC prime line is M is 1. Which is greater? Less than 1 or is 1? Is 1 is greater. Greater activity means greater free energy. The phase which refers to higher free energy is actually metastable and will be eliminated. Lower free energy, decreasing free energy, delta G is negative, is the stability, okay? Towards the equilibrium, delta G is negative, is the spontaneous process, okay? That means that gives rise to actually the stable. Lower free energy is the smaller free energy gives rise to the stable state. So this activity wise, well, you could say activity is 1, activity less than 1. Hence, this line is correct line. The one which gives rise to activity lower activity and which gives rise to higher activity is certainly metastable line. In fact, BC prime is the metastable line. For a given state, it reports greater activity than a stable line, namely AB. AB says no, it is actually less than 1. And activity means free energy. So lower free energy and higher free energy. So lower free energy will be stable. So this is actually the reason. Okay, see. Is okay. So this is okay. Very good. Okay. So so this is so that's what that means. This is another way of talking the same thing. That is activity from activity viewpoint or free energy. Activity again related to free energy. GI bar is GI0 plus RTL area. You know all these things. So let me finish the incomplete job. Is what I will remove dotted line now. Now it is time. I am removing this also. Activity M solid is 1. I am not keeping this. I am just removing everything so that you don't have any trouble. Remove this dotted. This all. And activity part actually I will explain you. A, B, D. Yes, that's it. This is the whole diagram. But 2 lines still remains. These 2 lines I will show you. Give you and about this activity. This I will give you actually a short note so that you can follow. Remember, C is the melting point of this, and here this line is this was actually E prime I said. This is the melting point of the metal oxide. This I already told you. This is the melting point. Phase transform vertical line refers to a temperature. That is the melting point. This is the melting point. This is for the metal. So remove this. You write here what are only this. Don't remove this. This is metal solid stability field. So clearly see metal solid stability field, metal liquid stability field, metal oxide stability field, metal oxide liquid field. Again you remove this. Since these are actually construction, the two ends you write, right? On the right, on the left, right which is stable, on the left which is stable of a given curve, given line, or above the line, below the line, whichever you like. So this is actually DE, whole diagram, okay? So I think no problem. Clearly see, clear, remove this, B. Triple point. The D will be another triple point and coming to this, and this is MO solid. This you remove, all this you remove, all construction you remove. This is the diagram, okay? This is right metal oxide solid, you can write here or you can write in the middle. Metal oxide solid. You can write here, or you can write in the middle, metal liquid. Same. The entire area, metal liquid. This entire area, metal solid already. This is x-axis, the lines are actually, okay. This line name is, this point is AB. Oh, sorry, AB, A, B, C, D, E, F. This is C, this is C, this is C. I think it's correct now, okay. This is the name of this line, A, point A, B, C, okay, everything is now okay, huh? D is okay. The whole stability fields are there. This is the final diagram, okay. But anyway, I have not given you the last two lines, so can I remove this? This I can remove, I think. This I am removing. Okay, remove. This I remove. Next step. Okay, step diagram. Now, so first complete the diagram in the sense I have already shown it completed, but two lines construction DF and D, quickly it will be over. So now continue with the construction of the remaining lines, with the construction of the remaining lines. Stability diagram for stability. C is T melting, M E T melting, MO. Prime or E you might call. You might call it. You project this down here, it will be E prime, or this is the melting point of the metal oxide. This vertical line represents the melting point of the metal oxide, and this vertical line, the melting point of metal solid. So metal solid. So you have everything. So let's continue with the construct the remaining lines of the stability diagram. Stability diagram means what? Which diagram? Figure. Tell me figure 1A. This one. Remaining lines. Figure 1A. Two only remaining. Remember, I repeat, 1, 2, 3 done. DF and DE is remaining. So let us do this. So ABC over second, fourth. Equilibrium. MO solid. Yeah, the vertical line. MO solid. See, MO solid here. MO solid here. Here means here, and this is MO liquid. So this is MO solid, MO liquid coexistence. D. So that equation you have to get this quickly. MO solid is MO liquid. MO liquid. This stable line D, this is a construction actually. This stable line, metastable I have removed this stable line D, DE vertical. Stable line D represents this equilibrium. Represents this equilibrium. Okay, this equilibrium. D prime I have to remove this, but since I initialize so D prime means down, 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 extension backward. D prime being the, I have removed that, being the metastable segment. Being the metastable segment. Being the metastable segment. E prime is incidentally E prime. I have removed that, but in case I'm showing you once more, metastable, the E prime, it's D prime. So E prime incidentally is what? Incidentally D prime. Here I mentioned also E prime is incidentally the melting point of metal oxide. This is for the metal, that is for the metal oxide, MO, melting point of MO. We call this T melting, TM, MO. Okay, so this is the D. Acha. E is what? Which line? D is over DF. Since D is over, and I have already explained, so I remove this. Since I don't want to keep metastable lines, and also reference to that E prime also I remove. But you understand the E prime in the construction, E prime was there, and that is the D prime is the metastable segment, and this is to be removed. Okay, so we have removed them, but this diagram finally got back. But E line, okay, DF line. What equilibrium? Tell me what equilibrium? This is metal liquid and metal oxide liquid. Both liquid. Follow. This one metal solid and metal oxide solid. This is metal liquid and metal oxide liquid. Both with oxygen obviously. So equilibrium. What equilibrium? You can write directly metal liquid. Right? Equilibrium involving. You write this as you wrote, metal liquid, metal oxide liquid, and the gas phase means oxygen. Oxygen, what will be the reaction like? So reaction is metal liquid plus half O2 gas is metal oxide liquid, both liquid. So what is this? The line, what is the line? DF. I am not delta G0 is A plus BT, that you will do. Because similarly, minus RTL and K, RTL and half P. Same. So similarly you do. So the line, what line this will be? The line which represents DF. DF represents this equilibrium. This equilibrium. df prime being the, again I should mention that df prime this way, df prime. I'm drawing this way, dotted df prime. Df prime would be the metastable segment. Df prime being the, I've removed that, and I'll like this. If you come down here, df prime being the metastable segment. Once drawn, three lines, these three, I get a triple point. Three phase meet. Which three phases? Three lines, not only three lines, three phases. Metal liquid, metal oxide liquid, and metal oxide solid. At D, the second triple point. This is the first triple point. This is one triple point. This is the other triple point. Okay. So this is D prime. The point D is point D is the second triple point, or is the second is the triple point. So this part, since I don't want to, appearance is over, df prime being, etc. You understand, but finally you remove this. Any metastable thing will be removed from the diagram. Thank you. So this part is over. But about the activity that I said, yeah, you see, you see this point, okay, no? It's okay. It's okay. It's okay. It's okay. So now the last, this one that I said, thermodynamic. Thermodynamic. Actually, it's better I write here and give a star here. 4 star. 4 star. Where? Remove this from this. Remove this 4 star. Couple of lines that what I said, activity. Greater activity means metastable. The line that refers to a greater activity of any species, metastable. Lower activity, stable. Greater activity means greater finality. Lower activity means lower finality. The line which refers to a lower finality is the stable line. Okay, because we know actually the lower finality will be stable. So yeah, so that this I say. It's okay. It's okay. Okay. So yes, what I said, like this. Thermodynamic is 4 star. The conclusion, the concluding lines. What is it? This is thermodynamic justification. Thermodynamic justification of stable lines and metastable lines. Of stable lines and metastable lines. Via the comparison of activities. This is the okay. This is the topic. So what is the just couple of words or couple of one sentence or two sentences. The curve. This is the clue. The curve pointing toward higher activity and hence higher free energy, hence higher free energy higher free energy of a species in solid state at any given point at any given point or you may call it state given state is a metastable curve. Higher activity, higher free energy means metastable. Referring to this, okay, pointing towards higher activity or higher free energy is a metastable curve. On the other hand, obviously, the opposite will give rise to stable curve. On the other hand, the curve pointing toward a toward Babu কতক্ষণ? How much time left? Toward a
2 hours 2 minutes 17 seconds.
almost done. 2 to 1 or 2 minutes maximum. Toward a lower activity of the same species at the same point or state is a stable curve. This is additional explanation. This is additional explanation. Right here. Additional explanation. I have given you compatibility. I have given you in agreement, mutually compatible, in agreement, in harmony, stable combination, stable lines, 3 stable lines in perfect harmony, in agreement, compatible, and 3 metastable lines in perfect or in disharmony and incompatible to each other. This I said, this main thing. And other things, properties about stable, metastable, they alternate around triple point. I have said every other is actually stable, or you can or metastable. Okay, 6 segments. Okay, radiate out coming from the 6 segments actually radiate out from the triple point. This I have already said. You remember, but additional explanation. So you might be, you feel better off with this explanation of metastable, stable. So because stable, metastable is very important. Additional explanation. Okay. What is thermodynamic justification? Additional in terms of activities. Okay. Via the comparison of activities that might be interesting to you and helpful to you. Thank you very much with this. Okay, this actually with this we have completed this problem. Next class I am giving you example, 6 example. Next class, example 2. It is better I give the name copper sulfur system. Copper, sulfur, oxygen. This will be next class. So until then, okay, I thank you very much for your active participation and your okay, interest, sincerity. So we'll see you next class. Okay, for the time being, bye. Okay, thank you.